Okay, so every data structure, whatever we are going to discuss here, it has some characteristics, okay, by which we can define that data structure, okay. For example, if someone asks you what is stack, so we can define this stack with following properties, okay. We can define that stack is a linear data structure, okay. The first thing, what is linear mean? Linear mean a data structure in which whenever we are going to store some value, there will be a certain sequence in which we will store the values, okay. Every data structure in which you store the values with the help of some sort of order, some sort of sequence, understand? So we can say that this is a linear data structure, and there are two type of data structures, okay. There are two type of data structure. One is called linear data structure and the other one are called non-linear data structure. So what is stack? Stack is the first property of stack is that stack is a linear data structure. Understand?
Yeah.
Number one, this is the first property or first characteristic. Number two property is here. This is the last in first out principle. What is last in and first out? I have showed you here, okay. You can see here. We have shown here. When we added this 5, it was added on the bottom, okay. And then we add 10, it was on the top, and 15. So look at here. If this, you can consider this one here, okay. In this, when we will enter the values, it will be like 5, 10, 15. And whenever we are going to get the value from this stack, we want to get or retrieve the value from this stack, you can see that the top value will be retrieved, okay. So this is what is the last value we have entered is the 15, okay. And when we get out the value, the first value we got here, that 15. So that's why we say that the value that will last in, okay, whenever you will get the value from the stack, that value will be output first. So we call it last in and firster out, LIFO. Understand?
Okay.
So this is the second property of a data structure. So whenever you are going to define a data structure, you need to explain its basic properties. With these properties may differentiate, make it different from the other ones, okay? All others. Like Q, like he is saying that stack has one end, okay? We can insert the value into the stack from one end, and from the same end we can get back the values, okay. While there is another data structure that is called Q. It has two ways, from two ends from where we can enter and we can output, front and the rear, okay. So this is the third property of your stack, okay. One is the linear data structure. Second one, it is the LIFO principle. Third one, it has a one end for input and output, okay.
Yeah.
To maintain a stack, we use one variable or pointer that is called top pointer, okay. What this top pointer does? Top pointer actually points, mean it indicates the topmost element of the stack. Understand? If we go here and we can see here, like here in this example, I show you here, when the stack was empty, the value of top was 0, okay. When you inserted in the 5, the value of top becomes 1, okay. And when we inserted 10, the value of top becomes 2. And when we inserted 15 here, we can see that the value of top is equal to 13. So what it means that top is equal to 3, it means we have 3 elements in the stack, okay. And top is equal to 3. What to which value this top is pointing currently? It is pointing to 15, okay. The top most values of the stack. Understand?
Yes.
So these are basic properties. Whenever you are going to learn about any data structure, understand? First thing
Okay.
you need to know 3 or 4 basic properties of that data structure. Understand? So we can see
Okay.
here, this is the 4th property. By these 4 characteristics or properties, you can easily define a stack. For example, what is a stack? Stack is a data structure which is linear data structure. Okay.
Okay.
Stack works with LIFO principle, that we enter last in and first out. Okay. Stack
Okay.
can we can use stack with one end. Okay, what it means that we can insert the value from one end and we can retrieve back the value from the same end, as compared to queue. In queue we can see that there are 2 ends, one is called front, the other one is called the rear. And fourth and the last property of stack is that we have a top pointer associated with the stack that always indicates the topmost element of the stack. Because we can
Okay.
see here, when we enter the values in the stack, okay, the topmost value can be retrieved whenever you want to get out this stack. Understand? So
Yes.
this is the total about a stack data structure. Understand? To learn
Okay.
its philosophy. So first of all, learn its characteristics. Okay. And then the second thing we we need to learn its working. Okay. What is the
Okay.
way it works? Understand? So let
Yeah.
me show here how it works. For example, we scroll down and we have this array here. Okay.
Okay.
And you can see I had already explained this one. So first thing is that in stack, whenever you are going to insert the value, the insert function is called push function. Okay.
Okay.
Push mean insert. Understand? So
Yeah.
this was the stack, that is the empty stack, and we push 1, it means we want to insert the value 1. So push is an operation of the stack which inserts the value in a stack. Understand?
Yeah.
This is the next thing. Okay. Next, what is the next thing? We need to learn about operations of data structure. Okay. Whatever the data structure, you need to learn its operation. So we learned here the first operation of stack is push. It is the push operation. It takes one value as an argument. Okay. That value will be pushed, will be entered into the stack. Understand? You can see here,
Yes.
there is missing the top value. So this is now the top value becomes 1. Okay. 1 is pushed.
Okay.
Now we push 2. So the top value here becomes 2. When we push 3, the top value becomes 3. It doesn't mean that we are pushing 3, then the value of top is 3. Okay. If you push some other value like 10, then the top value will remain 1. Okay. If you push 10 and 20, then its value will be 2. Okay. So what can you can insert integer value, you can insert some character value, you can insert some string value, and even you can also insert some objects in the stack. Understand?
Okay.
If you have certain objects, like we worked in Java and we made their words. Okay. We made their some other classes like order, like product. So it doesn't matter. Okay. Whatever the stack, it can hold primitive data values, and it can also have the abstract data values, whatever you want to store in it. Okay. So this is how we can see here. Okay. And now we can see here the top value will becomes the 5. Understand?
Yeah.
So this is how it is working. Now this is insert, pushing the values. Okay. So when we push, when we getting the values from this one. Okay. One operation is inserting and other one operation is retrieving. So what is the retrieving operation in the stack? Okay, so retrieving operation is called pop. Understand? So these are the
Yeah.
operations in the stack. Okay, you can see
Okay.
here, first one is the push one, insert an element. Okay, the next one operation is pop, which deletes an element from the stack. Okay, and this one is the peak, which returns the element at given position. Okay, other one, all are the optional. Okay, you can, these are not compulsory. Understand? Whenever you are asked to implement a stack, these three operations must be implemented. Okay, is empty, is full, and count, change, display. These are optional operations that can be implemented to make more flexibility in the stack. Understand?
Yeah.
For example, where we can need it, whenever you are going to push a value, for example, here, this is our data structure. Okay, we are going to push a value, we can here, we want to push here like push 20. Okay, and before pushing, we must check that whether there is a space in the stack to accept the value. Okay, so there is available possibility, available memory where we can store the value of this value. So before pushing the element into the stack, you must confirm that the stack has availability to store that value. Okay.
Okay.
How can we check that one? So this is called, we will check that whether stack is full or not. Understand?
Okay.
So if every time you will push the value, before pushing the value, you will check the size of that stack. If the size of the stack is not equal to the top value, mean you have the stack of 5 elements and the value of top is also 5. What it mean that? It mean that the stack is full. Okay. So the stack is full. So it means you cannot, if you still perform the push operation, it will generate an error, and that error will be called overflow error. Okay, that will be called an overflow, and this will be an exception. Okay, your program can terminate abnormally. Understand? And whenever you are going to pop the value, pop mean that you are going to remove the value. You remove 15. This was get. I was just write this one to understand. Now we have known that the get operation is called the pop operation. Okay, so we are going to pop here. We are going to pop here, and this add is now we have learned this is a push. This is a push, and this one is also push. Understand? So push 5, push 10, push 15 mean that insert 5. Insert 10 and insert 15. Okay, and when you are popping it, pop 15, it means sorry, when you pop, the top element will be removed. Okay, 15 will be removed. When you pop 10, next time you again pop, then the next value will be removed and same. And when, if we write here again pop, okay, so what will happen? It will go there and it will try to pop the value, but still, but the stack is already empty. There is no value in the stack because the value of top now becomes the -1 or 0. Understand?
Yeah.
So there will an error will be generated, and that error will called underflow. Understand?
Okay. Yes.
So to avoid these two exceptions, understand? You are going to store the value. You will check that whether there is an exception, there is a chance to generate the overflow error. So you can make here is full, okay, function. And when you are going to pop the value, you can check that is empty. Okay.
Yeah.
Understand? So basically, these are two operations that are performed every time when we check the push one or pop one. So that's why in most of the tutorials, okay, in most of the tutorials, you will see that is empty will be also an operation, okay, which will determine whether stack is empty or not. This will be of Boolean type, okay. It will return that true. Okay. When it will be empty, otherwise it can return the false. Okay. And then the is full and it will return true or it can return false. Okay. And what will happen that we will push the value if is full will return false. Understand?
Yeah.
Is full true mean it is full and we will push the value. So what will be the logic of push? Okay. The logic of push will be it will be pushed. Okay. When is full will return false. Understand?
Okay.
So when it will return false, then we can see that we will push the value there. So the next one is called the peak. Peak is to retrieve the value. Okay. It will return the top element. It will not delete the element like the push does. Okay. And then we do not need to work on count, change, and display. We can display it. Okay. If we want to print the stack, so we can make display and all the contents of the stack will be printed there.
Yeah.
You understand?
Yes.
So this is how we need to learn first about the working, the operations, and how the values are actually stored in a particular data structure. Understand? Now, if you have the concept, understand, you have the concept, okay, then you can write the code for this push function, okay, using any language, okay. You can write the code for pop function. You can write the code for isempty. You can write the code for that is called the implementation of a stack in a particular language. Understand? So you can implement with the help of any language, and you know that we will implement with the help of Java, and we will try to create a stack with the help of array. Okay, with the help of array.
Array, yes.
We will define a stack of let's suppose 10 elements. Okay, so we will create an array of 10 elements, and then we will define the functions, is full function and is a empty function, and in this way we will use that one. Understand? Whenever we will push the value, we will increment in the top variable, and whenever we are going to pop the value, we will decrement in the top value. Understand? Whenever you are going to push the value, so what will be happened here? Push will get an push will take an argument here. Okay, that will be whatever the argument, and whenever we are going to push, we will know that the top element will be plus plus, and whenever we are going to pop, the top variable or pointer will be minus minus. Understand?
Okay. Yeah.
And before pushing the element, we will check that whether is full, we will call the is full function. And whenever we are going to pop, we will check and we will call the is empty function. Understand?
Yeah.
So we will try to implement the stack with the help of array first. Understand? And then after this, we will make a class stack, and we will implement the stack as an object. Understand?
Yeah.
Okay. So let's start implementing the stack with the help of Java code and using the array. Understand?
Okay.
Okay.